the whole idea of the Buddipole is basically for kind of expedition DXing. So you have these guys, Buddipole has a whole kind of thing that they organize and do where people go off to some island in the middle of the Atlantic or the Pacific, set up a Buddipole on a sand dune and see who they can talk to QRP around the world, right?
Cool.
And it's ideal for that kind of a use. On the other hand, if you're talking about field day, not so useful. And there's a reason why, and I'll get into that. Now, as far as what you get, what you might want to get as far as it goes, the basic kit that I would recommend if anybody's interested in this thing is the Buddipole Deluxe kit. And nowadays that comes with about a 4 foot taller mast or 5 foot taller mast than the original. I have the original here. And that taller mast is a good thing. So this is about 10 feet when it's all set up at the highest point, and the new one's like 16 feet or something like that. So it's a little better, it has a little more reach. So what you get is the tripod base, the telescoping pole, you get a couple of loading coils, you get what they call the Versity for the top, you'll get a couple of antenna arms, and a couple of whips. And you'll get some clips for the loading coils and a nice neat little carrying case, and you'll get the 50 feet feed line cable with a PL259 and a BMC at either end, right? So that's the basic kit, and you'll probably find that you immediately want to go back onto the page and get some more accessories because there's so many more things that you can do with it. So first thing is, maybe I'll just start setting it up and talk about the pieces as I go, all right? So first thing, I always carry these two pieces here separately because they go into the case more easily when you do that. Mm-hmm. And so that's just a little kind of a use thing that makes things a little easier. And there's a little...
Can you say the names of them each time?
Yeah, this is just the tripod base and the telescoping mast.
Oh.
And I usually have to turn it upside down so I can see when it's clear. Here we go. And you usually want to get the thing so you can see there's a little hole here that keeps it from coming apart even if the screw's not tight. In fact, you don't actually tighten it up.
We should move our chairs up. We should move our chairs closer down. Yes, we could.
Yeah, you know, I used to teach high school. The first day of school, everybody would sit in the back of the room. And then I would go to the back of the room and start the class. It really upset me.
Then we have to turn around.
Yeah.
I think they're using those down there, but what are they calling it? Parks on the air?
Yeah.
They're using that, the Buddipole.
Yeah, so there's a little locator hole inside the outer tube here that this screw goes into. You're not going to tighten it against anything. It just prevents the pole from sliding through. That's all you have to do, right? And then, like any tripod, the strongest point is going to be with this more or less straight across here. It doesn't have to be perfect, but something like that. And then you can tighten this up a bit. And then it has telescoping legs. So we'll put those out. All right. Try not to hit you in the face with it. And so basically at that point you're ready to start assembling it. So this is just the mast. Now, you obviously you want to get this as plumb and level as you can for obvious reasons. And you have to check the weather too, because you might be getting to a stage where you have to put up some guy ropes, and I'll talk about that sort of as we're going here. So we'll bring up the first section, and don't be in a big hurry to get your sections up, because then you find out I forgot to put something on there, and now you got to pull it all back down again. And of course, you always want to start with the smallest section first, and put the thing with all the other sections inside of it up. I've seen people do that. All right, next up is what they call their Versity. Now I have some screws and a screw and washer here. And because when I go out into the bush, I put the HF on here, and I put my dual band UHF, VHF on here, unless I'm gonna do a vertical with it, all right? So this is called the Versatee, and then what I want to do is hold this up. You've got your center conductor, your shield, and you have this for vertical, right? So that would be where the center conductor or the main mast of the antenna and shield here. So you can do a vertical antenna, or as we're going to do this evening, a little dipole setup. And this has little holes for passing little guy ropes through. So what I did was I went over to the commercial fishing outfit and got some good netting type rope that's really strong and holds a knot. That's very important, right? Commercial fishing. What's the place down on the road here in town?
Yeah,
Red something.
Loft.
Redden?
Yeah, Redden's. Yeah, that's where I got it. All right, good ropes there. All right. So this is basically a pipe fitting. Now I was in the movie business for 20 years as a sound technician, and I have a 16-foot carbon fiber Buddipole, and I put a little adapter on it with a pipe fitting on there, and I can put the Buddipole Versatee on that. So I didn't have to buy their second, get the taller mast. I have another mast.
What do they call it? Folding? Is that called folding?
No, Foley's a whole different thing. In fact, my first job in the movie business was as a Foley artist. All right, so before we go any farther then, so we're ready to start assembling the antenna itself properly. So what we're going to do is we're going to put the solid antenna arms on first. We're going to put the loading coils on the end of those, and then we're going to put the whips on the end of those. And then we're going to stop and assess what we're going to do next, right? So these just thread in, and there are two different lengths of this. This is the, actually three different lengths of these now. These are the standard ones, which are what, 22 inches, I believe. You can get a 33-inch one, or I think you can get an 11-inch one now.
Is it the deluxe comes with all of them?
Yeah, the Buddipole Deluxe comes with these two.
Oh, so you gotta have the other lengths.
Yeah, and there are a lot of accessories for this. There are flexible whips. There are all kinds of different things you can get for it. All right. Next up, loading coils. So, what side is red and what side is black? Well, you just check here. You've got a red coil. Now, the only reason that's important, there's really no difference electronically or electrically between the two coils, but they have got a set of instructions that you can use to tune these coils, and it helps if you're not trying to remember, oh, I put them on backwards, right? You have to do something different. The other thing another accessory that I want to get for these is they make a little knurled piece that goes in here, so you're not twisting on the crimped connection all the time. Real good accessory you have, they're like $6.50 each, right? So I was just looking at those tonight. I'm going to order about 4 of those. Okay, this one goes on.
In case you butter one up.
Sorry?
They're aluminum probably, so that's in case you butter one up.
Well, best thing is you put them on there, you leave them on there, and then these connections never get strained again, right? So it's like anything else with use. Now I should actually, before I do that, let me take this one back off. So the coil reactance and capacitance is going to be adjusted by, I'll just take this off for a minute. This is another non-Buddipole accessory that you definitely want, and I'll explain why there too.
Velcro strips.
Well, Velcro strips. But what happens is this coil, this loading coil, affects the frequency that the antenna tunes up to. So if you touch this along different parts here, a different frequency will become your most optimum frequency. And they make these little clips that hook in, and then you tighten them up, and I'll see if I can do it without having to fall off, because that's what usually happens. So I'm just picking a random spot on here. Okay, and now that's attached to just one winding of the coil. And then you can plug in the grounding coil, and part of the coil is now dead, and we're only using another part of it.
How's it attached? It's screwed in?
There's a little hooked tab on there that goes over the wire.
Okay.
Now, the reason I stopped to do this now, I'll leave this on there, is you'll notice, and I'll just pass this around quick, you notice that there are 3 relieved areas around the circumference that you could get one of those clips under, and you can't get the clip under anywhere else.
That makes sense.
So pass that around so people have seen what I'm talking about. Now, the reason for that is you can get close to the frequency you want to be the tune frequency with whatever winding you're on, but you might be off, 500 kilohertz. And that's where the 3 different ones come in, because now you're adding a little bit more of a rotation of a wire. Now that's an unadvertised feature. They don't tell you that in anything Buddipole does, but if you know a little bit about electronics, you realize, oh, I'm going to change the size of that coil. So it's going to be electrically different. Now, does everybody here, who does not know what SWR is and why it's important? Anybody? So you all know, right?
Refresh me.
Standing wave ratio. All right, let's do a little quick sidebar lesson. When we send the signal up the wire to the antenna, in this case it's a dipole antenna, so it's going to go out to the end of that antenna and bounce back. So there's like a reflective thing going on. But it's a sine wave. What we want is, we want the sine waves going and coming to be in perfect sync, so there's no standing waves, hence standing wave ratios, and no standing valleys or dipping valleys. So what we want is, we want the antenna or the radio to see what looks to the radio electronics like an infinite path. And if you get the waves in sync with each other, you have a perfect 1-to-1 standing ratio and no anomalies. Now in practice, it's almost impossible to get 1-to-1, but occasionally you can do it. And if you want to spend the time, you can tune an antenna perfectly. You can get it right at 1-to-1. But it's not easy to do. And the idea is that for the best impedance and the best power output of the antenna, you want the standing wave ratio to be as close to 1-to-1 as you can get it. So, this is where my Velcro comes in. So we go to all the trouble to tune this antenna up and get it just right. We don't want it to change on us. Well, it so happens, like what we're going to do with 20 meters this evening, because that's the easiest one to do, 20 meters has no connections needed. You don't have to put any of those little clips on for the antenna to be in 20 meter band. You just adjust the length of the whips, right? So I happen to be at Sprott Lake. And if you've ever been to Sprott Lake, you know that every afternoon the wind starts blowing. Well, so I'm down and looking at my radio, looking at my standing wave ratio, and it's jumping all over the place. Guess what was happening? These were bouncing around and touching all over the place, and my standing wave ratio was just, a disaster. So I said, okay, I'll fix you. It was so bad that by the next morning, I just basically cinch it off back here, right? By the next morning, though, I didn't do that right away. Next morning, it had blown so much that these both broke off. They whipped back and forth from the wind until they actually broke. So you need a couple little Velcro straps. Okay? You seen it?
Oh, sorry.
So that's the kind of practical experience that I save you a lot of trouble just with that one little piece of knowledge, right? That's why these kind of meetings are useful. So you see the 3 relieved areas?
Yep.
Yeah, and that can be really important.
And we didn't play around with the little screw-on bit last time we were using these things. It was just setting it up and standing in.
And with 20 meters, you don't use them?
Depending what you're using it for, what meter band.
Yeah.
Now you may notice as you've been passing around, there's a couple of them have been painted. So Buddipole sends out a little diagram that you can look at, and it'll say, okay, for 40 meters, you want the clip to go on X number of windings down from the end. And they have very conveniently painted those spots for you so they're easy to find. But then you can play with the rotational part of it to dial it in even closer.
So there's 3 on each colored line, 3 relief areas?
One has, I think one has four.
This one has blue lines.
Oh.
Yeah, this one has 3 or 4. Yeah, this has black, blue, and red, and this one has red and green, and I think that's it. All right.
I mean, the parts where you can adjust it just a little bit on one line, or is it just one spot on each line?
Well, no, there's like a little area underneath the wire there where there's
Yeah.
room to fit the clip in, and there's 3 of those around
Right.
the circumference.
So that's where you could get 500 difference?
Yeah, it can make a difference, yeah.
Okay.
All right, so we'll just carry on with this. I'll get it on here.
Yeah, it's probably like winds can be really weird and strong.
Yeah, and every afternoon, well, in fact, all the lakes are in long valleys on the island, and they all get the katabatic winds at the end of the day, so.
Yeah.
All right, so we'll just strap that back a little bit there. And get the other one, strap it back a little bit. Anyway, that was just, like, I actually wrote to Buddipole and said, you know, A, put Velcro on them yourselves, and B, tell people about this, because it's a pretty common issue.
Mm-hmm.
All right, so just don't let your metal tip touch the bar there. All right, so now we're getting close. So the next thing is the whips. I mean, all just keeps going here. Oh, which one? There we go. So we started with the base, put on the Versatee, put on the arms, put on the coils, put on the whips. There's a little accessory, which we'll put on here in a minute, called a rotating arm kit, which gives you even more versatility, which I'll explain in a minute, because you can do an L-shaped antenna and one kind of thing or another, right? We'll get to that in a minute. Now, the next biggest thing you need to know about this is that you need an antenna analyzer. This Buddipole and any field antenna that's not pre-built to a certain frequency range, you're dead in the water unless you have an antenna analyzer. You just can't, you just be guessing. Now, with experience with the Buddipole, you can actually dial it in pretty close. In certain frequencies, I can get it, you know, really close right to begin with. But we'll look at the analyzer in a minute. So having done all this, that would be the basic Buddipole, and then you would set your whips to whatever the length they recommend as a starting point. We'll put the antenna analyzer, we'll do that in a minute, okay? You get it fine-tuned, and you should be ready to go. For this configuration, now there are a lot of other configurations, and I'll talk about those too in a few minutes. But right now, what I'm gonna do
So the whips, do they extend?
yeah, they go out quite a bit. We'll see in a minute. What I'm going to do is put on the rotating arm kit and show you why it's a good accessory to have. And again, not very expensive, but doesn't come with the kit. All right, so I'll just take that off. And like this here.
By the way, we have 2 here, right? People wants to borrow. We have 2 kits like this.
2 Buddipole kits, and we have a rotating arm kit.
Actually, I bought our one, and I think we have the locks, the new, because we have all that stuff. We don't have that little black thing there too, though. That little.
The ballad?
Yeah.
I'll get to that in a minute too.
But yeah, there's one more left.
All right, so take this off because I don't want to poke anybody in the eye when I do this next bit. All right, so the rotating arm kit, you can get your basic dipole, which is what I'm setting up now, just to show you guys. But it also prepares the Buddipole for a whole raft of other uses and configurations. So I'm just going to throw it on now.
Let's say you want the other configuration, does it matter if you put them just in case, or it's really just if you want to start moving the configuration?
This is strictly for the configuration of the arm.
Configuration.
That's it, yeah. All right, so now that I have that like that, I'm going to turn this so that I can put the arms back on without hitting you guys in the face with them. right, which I'm sure you'll appreciate. Oops.
So we'll have to move back.
Notice that I've reversed where the black and red were because of how I turned this, but they're still going to the correct side. Now, what I can do now with the rotating arm kit is I can move either of these arms or both to a different shape. So I can do a V, an inverted V, a sloper, and depending on the situation and exactly frequency range, everything else, and it's just a simple matter of loosening one of these off until I can get it out of the locating pins. So I'll just pop that off there, if I can there, and just find the next locating pin, and in it goes. The pins go back into position,
Oh, cool.
and you can get your different angles. Okay?
You said you can get an inverted V?
Yeah, just raise it up and do this.
Yeah, so
Right?
that's.
Yeah, well, again,
Yeah.
now, that's a really good point though. You don't want to do your inverted V, you can't even extend it the whole way
No.
at this height. So what are you gonna do? We're gonna do a little bit at a time, right?
Yeah, so
Okay.
you do it. right
Yeah.
there and then-
Now, for the 20-meter range, they recommend, I believe that the red one goes out 6, or the black one goes out 6, and the red one goes out 5.5. But I found out from personal experience with this particular setup for 20 meters, it works better at 5.5 and 5. Okay, so let's just see. So this is one length here. So this is 2, 3, 4, 5.5. All right?
Right.
And if I have it backwards, doesn't matter. This will be 1, 2, 3, 4, 5.
And did you find that, let's say, because you know this Buddipole, when you do this, if you tune it at different places, does it change how much you're tuning it? Or you like, because you know it and stuff, now you know that 5 and 5.5 should be good? And
Well, antennas are affected by topography, by soil and stuff, so this is a starting point.
Starting point,
It's
okay.
always regarded as a starting point. That, I mean, you'll be relatively close based on, the design of this, but it's not gonna be exact. So,
so you always, you
this is
literally
where,
always need the.
this is where this comes in, right? So let's just take a look here.
Question, why would it be 5.5 and 5 and not 5 and 5?
That's a
Just
question
one-
you have to ask
Right.
Buddipole themselves and how they design things. It probably has to do with resistance or capacitance of the coils.
Theoretically.
Probably do as it coils.
Okay, but theoretically, the dipole is the same,
Yeah.
the ways, so it's just.
Yeah, it's a slightly off-center dipole is what you wind up with
Yeah.
for this. That isn't to say that you couldn't tune it with equal lengths, but it might be a little.
Might be off over.
It might be a little more finicky. So, yeah,
Oh, did you say it was 5.5 and 5.5 for the rotating arm?
no. Rotating arm just has to do with angle.
Okay, so,
Right.
so either
Yeah.
way, the book was wrong?
Like this.
You're right.
Yeah.
But the length is still 5.5, 5.5, you've switched
5
it.
and 5.5 is
Oh,
what I
five.
found. 5 and 5.5, yeah.
Okay,
So, all right, so what we want to do now is start getting ready to test. So we're going to have to hook things up. So I'm going to show you a few more bits.
But that's for 20 meters,
Mhm.
not for anything else.
right.
No,
but
that's right.
it's-
You have to look at their reference guide, their starting guide. Here, let me raise this slightly so I'm not looking under it here. That's better. Yeah, so you start with their reference guide. Now, one of the biggest complaints I hear about the Buddipole is, oh, it's such a pain in the butt to use. Every time you want to change something, you've got to take it down and do that, and that's true. And if you only use it once a year, that is going to be annoying. But when you use it all the time, you develop a very quick feel. Like I can switch between 20 and 40 meters now pretty seamlessly, right? But it's just a matter of how used to it you get. But like I said, if you're talking about field day where you're jumping around all kinds of frequencies, the Buddipole will drive you nuts. But if you're talking about a DX contest, and you're sticking to a certain band and whatever, then this is a great tool for that kind of thing. right? Or you're joining a net that you join every week, or you're out camping and you want to join the net that you join every week, you know, that kind of thing, right? So it works pretty well from that point of view. So we're going to, I'm not even sure like what frequency we're going to get close to here, but I have to show you a few more parts as well. So what the Buddipole comes with, in addition to the cable and everything you see here, is you'll get a little connection piece that your cable connects to. So this one is just a straight connection, which is why I'm not going to use it, but I'll show it to you. And let's see here. Probably going to bring some of my other adapters, but it doesn't matter. Got to unwrap everything here. Get some cable out on the floor.
And when you said you use it like with VHF and HF, do you put two different cable or everything goes through one? So?
Everything goes through one cable. That's why on my all-band radio here, I have a little whip here for UHF and VHF.
Yeah.
But you can rig up a J-pole. Okay. So there's this. Okay.
So basically you put the antenna on the mat, but you don't plug it through the same kind of cables.
So superficially, yeah, it's all going to go through these things. But you see, these superficially look somewhat similar,
Yeah.
but they're quite different, and here's why. This one goes with the multi-range balance. This one has a choke built into it and comes with the Buddipole, right? So your BNC goes on to here, and what I normally do is I'll take this here to connect it, but also I like to slide the sleeve up here to hold it so the cable's not pulling on it, because these are fairly light-duty banana plugs,
Yeah.
right? So we'll come up here, we'll plug the black plug into the black side, the red plug into the red side, right? I'll come here and get a little slack, take some of the strain off of it, and then do this, right? So it's not hanging off of these two little plugs. So just kind of common sense with connections, you never want to put a lot of strain on there. So why do we need a choke? Who remembers why? And what is a choke for that matter? Well, there's a little coil in here, right? So what's the choke do?
Stops RF interference, right?
Yeah, common mode current from coming down the feed line, getting RF frequency interference in, you know, you can even get shocked on a higher power radio and whatnot. So that takes care of that. If you opt for the somewhat expensive but very nice multi-range balun, here it's a balun's automatically a choke. Mm-hmm. And then this goes on top of that. Has a little thing here to hang the wire on it, right? So that you don't have any strain, and it's the same kind of thing. Now, this is 1-to-1, 2-to-1, and 4-to-1. How do you know which one to use? Maybe 4-to-1's better than 1-to-1. Ooh.
They don't tell you?
How do you know what kind of a balun ratio you need?
Look in the book.
Nope. No,
No.
that's not the way to do it. Knowing why is the way to do it. You're going to learn a lot of stuff about this tonight.
It's frequency related, isn't it?
Nope, it's impedance related.
Impedance, yeah.
Okay.
Okay, so there are a lot of different antenna connections. We can use just a random length of wire.
50 ohm.
It probably won't be 50 ohm. It'll probably be 450 ohms.
Yeah.
Right? All right, so the radio wants to see 50 ohms. So what kind of a balun does a 450 ohm antenna need? needs a 9-to-1 battery,
Yeah,
right?
Yeah.
So whatever the impedance is divided by 50 is the ratio.
Right.
right.
Make sense? So it's impedance ratio compared to 50 ohms desired, right? That's a critical thing to know. You know, I kept asking radio guys for years, well, how do I know what balun ratio I should have? Well, a bunch of bullshit, pardon my French, right? Right?
So now to know the impedance,
Never the total.
know the impedance of that long wire, you'd have to know what that particular.
And how would you know it? Well, you have an antenna analyzer, that's how you would know.
Or can you get that from a chart that says how much impedance on that particular kind
Well,
of
typically, we all know from experience over, you know, the 100 or so years of radio, we know that certain types of antennas tend to fall in particular ranges, just due to their
Yeah.
electrical characteristics. So, in a sense, you could look it up.
Yeah.
But you always want to check, because that is going to affect the power output, and also it's going to affect SWR and all that, and could affect the radio too. All right, so let's just see where we stand, and I'll show this to you, and then we'll bring up another technical thing that has to
The
do
size of the wire would have a difference.
Hmm?
The size of your wire would have make a difference too.
That's right, yeah.
Because the heavier,
Well, it will, but it's not going to make any difference to the SWR, but it may be how much power you get out
no,
of
just
it.
the impedance.
Now, you guys have one of these in the program, so you've seen this before, right? By the way, I've been corresponding with Katerina Bystriakova, a rig expert in the Ukraine since before the war started. And we really need to support them. They're still operating. They've got the team scattered. They were in basements. They were hiding. Some left the country. They're back in operation again. She had to leave with her daughter to get out of Kiev, where she was. That's where they're located. And it's been, when I saw this coming, I wrote to them and I said, I hope you guys are making some plans. And I kept in communication with her throughout the war, and they have managed to survive. But boy, I'll tell you.
Didn't she
it's
go
been
back?
pretty bad. She's back now, yeah. they're all-
Because she sent her daughter with her mother.
So they I mean, tell you, those people have guts.
Yeah.
I'm telling you.
for sure.
They got big time balls.
Anyway, pardon your French.
Yeah.
Okay. So now what we're gonna do is we're gonna set our frequency. So I'm just gonna randomly say 14,225, somewhere in the middle of 20 meters, right? So that's number 2, set the frequency. So 014225, and we'll scan SWR and see what it's doing. And it's gonna come up with something here. I have no idea what it's doing. And we're not even close.
We're not even close.
Not even close.
What's
right?
it say on there?
Hmm?
What does it actually say?
It's
Oh, we're
10.
we're up near 10.
It's reading the
Yeah.
difference, the ratio.
So, but I've only got I'm gonna just expand the range here. So let's just do the range. Let's exit out of this. Okay, let's just set the range to, let's do,
Yeah, like if you ever watch one of those things, high, so it's kind of a high.
Yeah.
So the SWR higher up like this,
Yeah.
and then lower
Okay.
up, so you should see kind of something
See
like
a
so.
scoop.
That's where
So
yeah,
I
that's-
did-
Giving a graph, okay.
plus or minus 10,000 hertz.
Yeah.
Kilohertz, I mean.
You're still high there.
And so it's actually tuned right now for, let me go down there, 40 meters. All right?
And we should be at 20.
Yeah.
20.
And what I probably made a mistake is 40 meters you don't need any plugs for. So let's do 40 meters. Let's try, what's the noontime net? 7283, 7284. Yeah, okay, let's try that. That's probably a better choice. Okay, let's cancel. Let's change the frequency again. 7284. All right, now we'll do it. And we'll go 4. There we go. Man, oh man. Right on the mark.
Right on the money.
All right.
Oh, wow.
Okay, but now,
Right down there.
okay, but now I'm going to do plus or minus 500. Okay, and we'll see how close we really are. So we'll go back to the range, and all I'm doing here is gives me the numbers, so I'm gonna go 001,000, that'll be plus or minus 500. Okay, and now we'll scan the SWR, and we'll see we're probably not exact. Okay, so it's actually, let's see what frequency it says it is close to. So 7184, so we've got to do what now? We've got to go to a higher frequency, shorter and shorten the antenna.
Yeah.
Okay, so let's do that.
So on the analyzer, you can find out what frequency is closest to?
Yeah,
And then just.
I type in the frequency I'm looking for,
Okay.
and then it tells me where it's at.
Oh, okay.
Okay, so we'll go down half here. And well, where's my half one that I had over here? Well, let's go down. Is it here?
I think, yeah,
Let's
it was
go
there,
down
so,
half
yeah, it
there.
was there.
Yeah, now let's see what it does. It's probably too much, so let's see what happens. So I'll just go.
So when you would do your analyzer, would you put the antenna all the way like the way you want it, like all the way up and all that, and bring it
Well,
back?
I'll come to that. So we went too far.
Okay.
All right, so now we'll just kind of edge out again. So I collapse that one in, so we'll go a quarter. We'll go a quarter. But see, we're radio people, so we like finicky, play with it, see how close I can get on a guess, right?
What about adjusting just one end?
I'm sorry?
What about adjusting only one end?
Well, it is a dipole, okay, that's closer, a little closer, but not much, all right? So let's try it again. Then we'll narrow it down to 250 either side, all right? So we went too far, where am I here? Let's go back in a bit more. Actually, not in. I wanna- Yeah, no, we're gonna go down in frequency.
Yeah.
All right, so we want to go back out a little bit more. See, I'm thinking upside down. Don't get yourself
Yeah,
confused.
we are going back to where we were.
Maybe.
Yep. Looks good.
All right, you see that?
I see that.
Well, you see the little mark in the middle? That's our target.
Okay.
Pretty darn close, all right? So now let's go narrower though. All right, let's see how close we can tune it. So I'm going to exit out of that. I'm going to go to set the narrow range, and this time I'm going to go to 500. So it's 0005, and accept that. Now it's going to be plus or minus 250. All right. So now check the SWR. I don't think we're going to get any better than that.
Yeah. So you're adjusting the range of the meter?
I'm shrinking
Finer,
down the
finer,
range,
finer,
right?
yeah.
Finer and finer and finer. Okay, now what is the actual SWR? So let's look at it. That'll be number 7, 1.17 to 1.
Wow.
Okay? Without this, you have no idea what you're doing.
That was my problem, I didn't have an analyzer.
Right? Now, the next thing is, we can look at all, we'll use show all. And so our impedance is 45.3 ohms, so it's not perfect, right? So it's a bit, this is where the compromise comes in, it's a bit off. You know, so you could keep messing around with this endlessly, trying to fine tune it.
Yeah.
But I tell you right now from experience, that's gonna work.
So the impedance is, that's off because of the tuning? or
The
because
antenna
of cable, or-
impedance, the antenna impedance is off by 5 ohms, right? So it's not ideal, but it's perfectly acceptable for what we would be doing, right? All right, so that's good to go.
And with that, you would be able to use the whole 40-meter band, or?
Well, no, and that's the next part I want to come to. That's exactly the right question to ask. So let me go back here and let me reset the range and go out a bit more like we were before. So we'll set the range to, let's set it to 2,000 this time. Okay, and then I'll rescan it. Okay, so there's reading it. You see it's filling it in. And we do the board here. Hopefully one of these is going to write. All right, so if this is our center line, this is our graph, and it's making something that kind of looks like this, right? So this is your SWR in this axis. So 10 is up here, and 1 to 1 is down here. We know we're at 1.1 something. Okay, and if we look at the graph, what we have, you could probably get away with like 2.5 or something like that and still have a reasonable chance of getting out. Better if it's under 2, okay? But 2 is right in the middle, okay? So 2 is like right about here. So that's a very narrow bandwidth. So that goes to your question, what you just asked, right? So acceptable SWR is going to obviously drop off. Remember, any antenna is only ever actually tuned for one frequency, and one frequency only, and everything else is a compromise. So
So at 2, how far off can frequency go there?
So that's how far off before the radio's not going to like it, right?
Yeah,
So
you're
you're going to
reflecting
have very,
more power back.
like if you have 100, like if I have a 100-watt radio on this antenna right now, on the frequency I've chosen,
Yeah.
it's going to be putting out 100 watts pretty darn close, 90 or 95 watts, right? But go out to a frequency over here,
Yeah.
it might be 30 watts.
Yeah.
Go over here, it might be 5 watts.
You're cooking the transmitter.
Well, it's just hard on the radio, right?
Yeah.
So, so now this is 40 meters, and it was my mistake because I just hadn't done this for a while. So, thinking it was 20 meters that was what I was shooting for when it was really 40. If this was set on a 20 meter thing, this would look more like this. So the higher up in frequency you go, the wider your usable bandwidth will be with the Buddipole. And the lower the frequency, it's going to narrow down. And if you get with the 80 meter coils and stuff, or some of the other things I'll show you here, you're going to have something that's going to be like this. It's going to be very narrow, right? So if you're a big 80 meter fan, or even 40 meters, and you want to do a lot of frequency hopping, you're going to be doing a lot of tuning. So suck it up and do it, right? Because that's part of what it is, right? And this is a field use thing, right?
Is there an antenna tuner you can use without having to tweak this all the time?
Well, that's a very good question. So you guys are getting ahead of me here. What is the eraser for this thing? There it is. Look at that.
Yeah, that might be it.
Yeah, looks like it to me. Okay. All right, so now depending on your circumstances and what you have available to you for power and stuff, you should always have an antenna tuner. The beauty of the Buddipole is that you can tune it to the frequency you want, but you have an issue if you go off that frequency. So in this case, I have 2 tuners for this radio, only brought one, and I love this for QRP out in the boonies because this requires no electricity. It's RF powered. So there's a procedure you go through. So you come out of the radio into the tuner and then out to the antenna, and then you put it in test mode. You transmit on AM, and there's a little LED here, and you dial in your impedance and capacitance here until the light is at its brightest, and you're tuned.
Oh, cool.
You can buy this as a kit, or you can have them pre-build it for you.
What was it called?
This is a ZN-2 ATU by MTech.
MTech, yeah.
MTech, right? These things are great. And I don't like putting stuff together like this, so I have them build it. Plus I can blame them if it doesn't work, right? Okay. And this is really set up nicely. So coax here, random wire or ladder line, anything you want, okay? So you can run random wire with a counterpoise, all kinds of stuff, right? So this is a great little tuner for, literally out in the field kind of work, because it doesn't require any battery power. It runs off the radio. It's got to have a good power supply for the radio. Okay? All right. So that's the kind of, so far, got more to come. This is what you consider be your basic Buddipole setup. It's a dipole. It's, you know, it's pretty straightforward to set up after you've done it a couple of times. Like, you know, I didn't consult any books or anything like that. I just read about this much, right? So, and that's the other thing. Don't get caught up in manuals. Understand how it works. Then just play with it. What's going to happen if you do it wrong? Somebody going to slap you on the wrist? No. Just keep playing with it, right? And you'll learn way more that way.
It's just not gonna work.
And like me, I momentarily, oh, it's lower frequency. Oh, that means I gotta go longer. So momentarily you get it backwards, right? It's okay. No one's gonna, it's not a test at the end of the day, right?
When you change the length, does that change the impedance?
No.
No?
No, it changes only the frequency. So, I mean, the impedance will change probably a bit. And also, I'm sure if I raise the antenna, the impedance will change, right? So I'm not raising it in here. Actually, I probably should raise it a little bit more. I don't know if anybody's on the air. Shall we look and see if anybody's on 40 meters? Just for the heck of it. Just put this up a little higher. By the way, telescoping things, always go all the way up and then back. I like to go back about 3 inches. So I've got one pole still has some strength inside of it. So let's just see if there's anybody doing anything with 40 meters. I have no idea. I didn't even look at any nets. You know, anybody know any nets that are on the air right now?
So now, is this going to be, I'm just trying to think, is this going to be directional? The way it's set?
Well, somebody else know the answer to that? I know the answer to that.
Yeah.
I think,
It
yeah.
will be.
I'm thinking it's directional.
Well,
Yeah.
It's gonna be off to the side.
all right, so a dipole antenna radiates 90 degrees to the axis of the antenna.
Yeah.
So the null is off the end, all right? Whereas if it's a Yagi, it's very directional. You know, if it's a loop, it's kind of omnidirectional, right?
So if you hear somebody and you want to give a string, you make.
Yeah, and in fact, Buddipole sells a mask from Mastworks that actually has a little crank down here, and you can change the angle from the ground without having to do anything. It's really cool. We have one for the program, 30 feet tall.
Whoa.
Yeah.
What kind of adapter do you have?
It's a mask like this one, but it's got a gearing mechanism at the base, so you can crank it and turn the antenna.
Oh, okay.
All right, so what do we got? What do we on?
It's like having a motor-driven, Yankee.
Okay, so now I mentioned before you could do various configurations. So we can have the we can have a sloper, we can have a regular V, an inverted V, and L. We can have you don't have to do this. You could put one of these here to make an L-shaped antenna that way, right?
And that becomes a vertical dipole, or
Yeah,
vertical, not dipole, but.
Is a vertical. Now, when you run a vertical, you want to run counterpoise. So let me just talk a little bit about some of the other configurations, and in particular, what you can do with wires. So what I'm going to do right now is take the whips off. Biggest thing is with something like this is learn to use it, be patient with yourself and with the gear, and then you won't get frustrated if you are trying to sort of will it to work when you're fighting a bunch of different things. It's just going to drive you nuts.
I was reading on their website that they have like a Nivis configuration with those two things. Did you try it?
Well, they have it here. That's kind of what I'm going to show you right now.
Oh, perfect. Okay.
Right? They have all kinds of things that people have tried. So the next little accessory, it's a really useful one to have, are these little things here. So basically, these go in the end of the coils. Now you're going to want to use the coils to cut down on the amount of wire you need. Okay, so you put these in here, like so. And then you can hold that and you can select that, put a couple of washers for holding wires on here. Clip a wire on, and that's what I brought these along to show you now. These particular ones here, you see I've got a little red mark and a little green mark, right? That I just put some shrink tubing onto the wires itself. And basically all I do is I slip this onto the terminal and unroll the wire out. And I have you can use a bush or whatever, but I also have some plastic stakes for like electric fence. Again, go to the feed store or whatever. Stick that, you just stick that in with your foot and tie the thing off on the end there. And presto, 80 meters, right? They also make an accessory 80 meter coil. So it's a bigger, fatter coil, right? So it's different reactants and stuff. So, and you can add to that. So there you could go to your 160 meters.
So what's
right?
that one? What are these for?
These are what they call their standard coil. They handles everything from 40 on up.
Right.
And then they have a larger coil for 80 meters.
So how much length does that coil replace, basically?
Well, 40 meters is 40 meters. So if you're going to have an actual antenna that's the size of the wavelength, it's going to be 40 meters.
Right.
So we seldom do that unless you have a lot of room.
That'd be
right?
quarter wave or something.
Yeah.
Right.
So this basically loads up the impedance so that you don't need as long a wire. Right. Same thing with the arms. Obviously not 40 meters long, but we were tuned in 40 meters nicely. Right. So you can string these out.
But they have like a chart or whatever to say how much you should string on for your frequency.
Nah, that's basically just play with it. So I got out some wire and started stringing it.
That's what you got in
And then you just fold it back on itself, right?
Yeah.
See how I've got that folded back on itself? As long as the electrical length, is not longer.
So that
the
won't
main
act
thing.
like a
No,
coil or anything?
no, not the way it is here, no. If it was in a loop, yeah, it would be, but just the way it is here, no.
Yeah.
Right?
It was tight.
You got the metal cord.
Yeah, you don't want to turn it in. You don't want to turn it into a coil.
So don't wrap it on metal.
That's a plastic.
No.
Well, don't even do it in the air. It's still a coil.
Oh, really?
Is there, have you noticed have you used 80 meter coils versus 80 meter wire?
I don't
Is
have
there
the 80 meter coils. Barry and Amanda do.
Oh, okay.
Okay, and they've got the taller masts as well,
Yeah.
right? But I haven't found I need them. I can usually find a spot even in a campsite where I can string these out through the woods or whatever, and it works just fine. Handles 100 watts, no problem. It's all good. And then if I need to tie it off with ropes, like there's no good place to stick a stake in the ground, that's when I use the insulators on the end, right? So I have a couple of alternatives. And then I also have, these are actually what Buddipole themselves sell. This is the wire for like counterpoises. So let's say I wanted to run a vertical. So I might take two of these arms and string them together, and one or both coils, right? Depending on what frequency range I'm going for. But it's a vertical now, and I don't have any radials. So counterpoise is your only real option. It's a compromise, it will work. So what you then do is you take one of these little things here onto here, and now you run your counterpoise a little bit off the ground. And it's usually they recommend you do an L with about 30 feet on each leg of the L, right? Works just great, right? Just works great. Now, I found out something about that astounded me, right? They say, well, try to string it about 2 feet off the ground through the bushes. Well, I couldn't dial in 40 meters to save my butt, right? And then I thought, well, let's just try fooling with the counterpoise, because I've done everything I can on the actual vertical. And with that, watching the screen on that in just SWR mode, I just lowered the wire down, tuned it right in, brought it right in. So I was about that far off the ground.
So that'll be like a real-time screen? As you move it around?
It's a real-time analyzer, yeah. Okay, so what else can you do with this? Well, like I said, there's various various wire configurations, and then, now I don't have all the accessories for what I'm going to tell you about, but you can look it up on their website. So they have two things. You can do a J-pole dual band for UHF and VHF. And they basically make a little piece that can go on here that you can put your stub and your longer for your two different frequency ranges. So that's like an accessory, some accessories you get and put it together. And they also make a 6 meter Yagi. So I know a lot of people like playing around with 6 meters. Uses all of these types of components, not the coils usually, but it uses the arms and whips and what have you, as well as a couple of extra connector pieces to build the Yagi shape. So you need more arms, obviously different lengths and whatnot, so you get your Yagi configuration. And then you can see with that, that's where the crank around Masterworks mass would be really handy, because now the Yagi is highly directional, right? Yeah. So anyway, that's kind of what I have to talk about. Like I said, the biggest complaint that people have is, well, it's so fussy. You have to play with it all the time. But as you can see, it really didn't take me long to suss out what I was doing. Again, not really a fun tool for contesting or whatever where you're jumping all around. But if you're doing DXing or specific frequencies or specific nets going out into the bush and you want to check into the noontime net or the BC Public Service net or whatever it is, right? You can easily set up for that frequency and it just works like a charm. I have been all over northern Vancouver Island and the West Coast, and I talked to Tom Aldred back here in Merville every time and never failed to get through, right? And your NIVIS question, unless you're doing a vertical configuration with this thing, they're all NIVIS because you're so close to the ground. So basically short hop, right? And
You're talking to Ukraine, but not on that.
No.
well, you could.
You
I,
could.
the farthest, see, I took this exact radio and the Buddipole with me on a trip to Nova Scotia. It happened to be field day weekend. I was there. And from Point Blomidon on Fundy, Bay of Fundy, I talked to a guy in New York. So that's not a bad hop, for 6 watts, right?
Yeah.
And
So, yeah.
yeah, it's only 6 watts. As far as my 100-watt radio on this, I've talked to guys in San Diego and Texas and whatnot, and it's no higher than 10 feet off the ground, right? So it's all skywave
So
angles.
that'll handle 100.
Yeah. Anything under 50, 60, 70 feet in the air is going to be somewhat of a NIVIS antenna unless it's a vertical.
What's that mean? That was,
No,
Near vertical.
Vertical
instead
is
of
skyway.
skyway.
Yeah.
okay.
Basically, you radiate the sky instead of.
Yeah. Well, it's like a pool cue, right? A pool ball. You're going here instead of here, right?
Okay.
And that's just because of the radiation characteristics. The ground is reflecting it,
Yeah.
so it's going straight up basically,
Okay.
right? Whereas if you get higher in the air, it goes off more towards the
And
horizon.
then skips around.
And Buddipole has a whole thing about different configurations of what angle of incidence you can expect.
Is that
on
what going to the inverted B does?
Yeah, and slopers and all kinds of ones. So
Yeah.
a sloper especially, you're coming off the side of it, right? So you can almost predict what angle it's going to shoot, right? What was I going to say about this? So, and I don't know what anybody else's experience is, but I find that low-level antennas, the optimum skywave is about the middle of Washington State and about Prince George or that area.
Like
So what is that, about 400, 500 miles or whatever, probably, right? That seems to be the optimum skywave for bounce, so not big time DX, but I was talking, I've just got 2 wires, nothing special, with a balun and 30 feet at the crest with an inverted V, and I was talking to a guy in Pennsylvania the other day, and then not long, a couple of years ago, I was talking to a guy in the middle of Russia, on 20 meters at night.
Oh, cool.
That's the advantage for emergency communication for this, because like we would want to talk to everybody, but if you're hamming too hard, then you could miss like talking. But because we have a cone that is a little bit, NIVIS is usually either army usually a lot or emergency. Like
So
Gold
then
River.
that was gonna start to go.
Yeah,
spread
like
all
for
over.
example, Gold River, if they try to do a vertical, all the mountains and stuff would
Yeah.
block it, but if they go up like this, they can kind of still talk.
Yeah.
So that's why conversation, and it's mobile, you bring it, it's.
Yeah, for emergency backup, you can't beat this. It's, you'll see me when I pack it up, it packs up really small. In fact, I have a hunter's vest at home, and I
You
put
can carry it all
this,
in there.
I put this with the cable into the little carrying case, and everything else is in my vest.
Oh, cool.
So I'm a walking radio station with just a little bag, right? So I literally walk off into the forest, right? So, so any other questions on that?
So it'll work 5 watt or 6 watt,
No?
and it'll take up to.
It'll take 100.
Yeah, 100 watt. I would go more than 100 watt.
I don't think if we are just regular amateurs, we can go 100.
But even if you do, like, for example, if you look in the States, there's sometimes like some of those people, they have like, they scream it out like, 2000 whatever watts. But the problem is that everybody can hear them, but then they cannot hear anyone because with your little 100 watts.
Yes,
So,
yeah.
so overpowering everybody is not really the greatest thing. And plus, the whole point of communication is that you're able to talk with two people. But if
Yeah, for sure.
Most of the guys that have go up over 100 watts